homework. Yes. Tell me your finding from yesterday until now still your fine. Okay. I guess I could draw that conclusion. Okay. Question 3, any issues? Question 5. Question 6. No problems. Wonderful. Okay, pass it to the front then. Once again, I realized I forgot to give homework for exercise 2C. Don't forget, I teach you all 2 subjects. Anyway, you're over there. Don't lie. Really?
You can see his IC.
What? Really? What I sing? No, you're sing, man?
You're singing. We didn't know the first one. It's a surprise. Ice cream is legit like.
Okay, exercise 2C homework. Question 4, 6. First, we finished this up yesterday already, right? So this one homework due next Wednesday. Right?
Second row also.
Yes, thank you. Dylan, homework? Huh? You need to catch up on what? All over. So when could I get all your homework? Give me a deadline, or rather give yourself a deadline. Sorry? So what is a good deadline? What's a good deadline? Can you finish a conversation with me first before you continue a conversation with me? Huh? Tomorrow? Please don't do it now. I want to start it. I want it in my locker by tomorrow, right? Okay, let's continue with our cumulative frequency. What happened? We open to your textbook, page 68. Okay, cost fund, by the way, $4, pass it to Bervin. Okay, Bervin will collect. Don't do it now, please. Do it after school. Why is the visualizer suddenly not working? Why? Okay. Okay, can we take out your textbook, page 68? I want us to recap what we had covered yesterday. Okay, so could you give this a practice now? Could you work on this? I'll give you about 3 minutes. Okay, 4 minutes, because I need you to construct the cumulative frequency table as well. Okay, so we did that yesterday. You can refer to the notes. Yes, do it in your notebook. Please work your brain and your hand, not your mouth. Are you done? Maybe 2 minutes more. Just go and show your answers on the whiteboard. Honey, we are on the table. that you compare your table and compare with the table that Joseph has filled up over here. Alright, any questions regarding filling up of this cumulative frequency table? Okay, so do take note that down here it should all be less than or equals to. Okay, and for cumulative frequency, we're just adding up the numbers accordingly based on the frequency table. So looking at B part I, we want to get 50 mm or less. So what will your answer be, Wei Chan? Sorry? 58? Do you say 58? How much? 32. Okay, so we get 32 insects that are 50 mm or less in length because we could just read from the table. So 50 millimeters or less, so 32 is the answer. And what about more than 45 mm in length? What will our answer be? See, 18. How do you get 18? How do you get 18? Plus 6 plus 2. 10 plus 6 plus 2? Or 10 plus 6 plus 2? Why would you want to do that? What was the technique that we learned yesterday for more than 45 mm in length? We can just take the total minus away what we read off. 40 minus 22. Okay? Why am I trying to encourage you to do this? Because when I'm going to talk about our cumulative frequency graph, you will realize you no longer can do 10 plus 6 plus 2. Okay, so when it comes to more than, we should take total number minus what we can read off. That will be the more than. Okay, and in part 3, we want more than 35 mm but less than or equals to 50 mm in length. Okay, what would the answer be, Katja?
32 minus 4.
32 minus 4?
28.
28. Okay, so that's because 50 mm we have 32, 35 mm we have 4, so we take the difference between these two numbers and we get answer 28. Okay, so let's move on and look at our cumulative frequency curve in our notes now. Okay, so a cumulative frequency table helps us to be able to translate the information onto the figure over here. So for instance, okay, just to show you as an example, if I want to find out, okay, in this case we have the maths exam score achieved by 120 students shown in the curve below. If I want to find out how many students actually got less than or equals to, let's say, what's a good number to take? Okay, if I want to talk about part I, okay, total, the number of students who scored 30 marks or less, right? Then I will look at the x-axis where it labels the score. 30 marks, I will read up to the curve and then read towards the left, which tells me the cumulative frequency. So in this case, I will find that there are 40 students who score 30 marks or less. Okay. So likewise, if I wanted to find out, let's say, number of students who scored 55 marks or less. Okay, if I want 55 marks or less, how many students would that be? How many students would that be? 55 marks or less. Noi, what do you think? And 102, okay? So you find that it may be difficult to read from here. I just realized I loaned my ruler to someone else who got it back. Okay, so if you look at 55 up to the curve, okay, you would have read off 102. So sometimes using a ruler to guide your sight will actually be easier rather than having to follow the line, because the lines can be rather tight sometimes. Okay, so that will be 55 marks or less. Okay, if I want in between, okay, let's say 30 and 55, then I will take that value minus away this value. Okay, What if I want more than 30? Okay, if I want more than 30, then I will read, okay, at the tip of the graph itself, okay, what is the number, which is 120, and I minus, let's say, 30 marks, which is actually 40. So I take 120 minus 40. Something that I want to caution you about is that when it comes to cumulative frequency curve, very often students actually think that 130, okay, is actually the total number of students. So please don't be misled by the number at the end of the y-axis. Okay, you need to refer based on the end of the graph that will indicate to you the total number of students. Okay, it is not all the time that in the question itself they tell you what is the total number of students. So we got to be very careful about that. Okay, so this is the total number of students. Right? Now, part 2, okay, we want to find the percentage of students who scored more than 55 marks. So earlier on, Noi has mentioned that less than or equals to is 102 students. Now that we want to find the percentage, I will need to consider 120 minus 102 so that I get the more than out of total number of students 120 and times 100%. So I will get 15% as my answer. Okay, any questions? Are you able to see from the back? Okay, then in part 3, we want to find the value of T such that 90% of the students score T marks or less. So sometimes instead of reading from the x-axis upwards to the curve to find the number of students, we would read from the left side down, okay, and find number of students. So we want number of such that 90% of the students got T marks or less. Okay, so we need to figure out how many students is this in the first place. So 90% of the student, number of students will be 90 over 100 times 120. So we see that there are 108 students who scored T marks or less. Okay. I'm just putting in this statement here about scoring T marks or less because if I want to do T marks or more, then it's a different process. Okay, but let's just deal with this first. So we are looking at 108 students. Go to the graph. I identify, okay, where is the 108, which is over here. Use your ruler to guide yourself, and you find that it is at this point, and that is 60. Okay, so 60 marks is what T represents. Okay. Questions? No? Let's move on. Example 2. Joseph, can you please wake up? Example 2, we got the less than cumulative curve. So, yes. Go back. Okay. In most cases, right, we are giving you a cumulative frequency curve that represents less than or equals to. Okay. Only in certain times that they will specify that this is a less than curve. Okay, so any point that you read from the graph, okay, it actually means that there are that number of apples in this case that are lesser than the particular mass. Okay, so in this case, we have this curve that shows the distribution of masses of 120 apples. In part I, we want to find the number of apples having masses less than 98 grams. So what would that be? Haley? 50. Okay, so let's do a check. 98 is over here. Okay, 98 grams going up. You sure it's 50? Doesn't it read right at the corner? It does, right? Okay, so this should actually be about 48. Right? So number of apples equals to 48. Am I right? Okay, when it comes to reading of a cumulative frequency curve, there are times where there is a range of answers that are acceptable based on the accuracy of the reading from the graph. But we try to read as accurate as possible. Okay, and in part 2, we want the fraction of the total number of apples having 117 grams or more. So, what would that answer be? Joseph? How do I get the fraction for the total number of apples having masses 117 grams or more? It came out nicely printed for you all, right? Okay. Hmm? 117 grams. 120 minus 76. Why 76? We want 117 grams or more. A fraction of? Out of the total 120. Minus 76, are we right? Hmm? 44, so you're taking 120 minus 76. Is it? Out of 120. So that's your working. Is this correct? For 117 grams or more. So Adia, what will your answer be? What's the answer? 120 minus 104. You agree with this? 104, Joshua? Okay. So read carefully. Okay. We are looking at 117. So each box is actually 2 units. So 17 will be half in between the box. Okay, and that goes up to here. Okay, of the line, and that will be 104. So simplify the fraction, you could use a calculator, and we get 2 over 15. Okay? And to find the value of k, given that 20% of the apples have masses k grams or more, how do you think we could get the answer? Teresa? What will you do first? Find the 80%. Why would you want to find 80%? Okay, because we want the top 20. Because they say or more. Okay, so that is 18%, right? Maybe just to translate that a bit. Okay, I'm not sure whether any of you actually caught that. Okay, so Carissa says that to find out what is the number of apples that is 80% first, because you're looking at kilograms or more. Maybe to actually avoid any confusion in terms of having to think of minusing and all that, okay, maybe what I would recommend to do is find the number of apples first, okay, that represents 20%. So 20% out of 120 apples, you get 24 apples. I'm not saying that Carissa is wrong, okay, her calculation will still get her correct answer. But 24 apples, okay, is actually kilograms or more. Okay, I guess it's a bad notation to use K for grams. Okay, so 24 apples are kilograms or more. What this means in the diagram is that there are 24 apples, okay, that is at a specific gram itself. Okay, so let's say it is this gram, okay, 110, right? In this section here, there are 24 apples, okay, that are 110 grams or more. So we want to figure that out, okay, but we are not able to actually read backwards so easily. So we go and find out what is the number to read, okay, and that will be by considering 120 minus away 24. So 120 minus 24, you get 96. So 96 apples are less than kilograms. Then we read for the graph 96. Okay, and therefore, reading the graph at 96, I would be getting 140. So this is 4, 8, 12, 16. Okay, so 96 will actually be here. I'm reading it off the x-axis. We get 140. Okay, so I want to draw the differences between example 1 and example 2, where example 1 we were looking for T marks or less. We just read off the graph directly. While when it comes to something or more, okay, I will need to do a reverse calculation. Okay. I also want to just briefly mention about this zigzag line over here. It is to allow us to skip numbers. It will appear very often in statistical diagrams. However, I do not encourage you to draw it in your graph, okay, for fear that you give me the wrong scale. Right, so we do not use a zigzag line in our drawing, but you will need to understand how to read it, that it just needs a skip of numbers. Okay. Now example 3. We are given a frequency table. We want to complete this cumulative frequency table. So could I just give you a minute, right, to actually solve this question? Fill out the table. What would the answer be? Answer? Yeah. Okay, so you should get these numbers. You all get it? Okay, 65. Okay, in part B, the question actually wanted you all to draw a cumulative frequency curve, but like I mentioned, okay, in the exam, you will not be required to draw one, so I extracted the digital one for you. Okay. So I just briefly mentioned about how this curve is being drawn, so that you can understand what is the statistics behind it, for you to process further on when we need more information out of it. Okay, so what we do is that we see that the amount of milk that is X liters lesser than or equals to 4, there are 7 cows for it. So at amount of milk 4, okay, I make a plot over here. Okay, so that is 7. And then when the amount of milk is less than or equals to 6, I make a plot over here, and that is 18. Okay, and then over here is when X is less than or equals to 8, and that's 35, and so on. Okay, so that's how the graph is being plotted. Then what a computer does, okay, or if you were to do it manually, you draw the, you connect, okay, the points using a smooth curve. Okay, so in this case, where did this plot of 0, 0 came from? Okay, it is because if the milk is lesser than or equals to 0, then there will be no cows, but it's just purely an estimate as well. Okay, because having no milk does not mean that it's 0 cows, because you can have many cows but no milk still, right? Okay, so depends on the question. Sometimes it may start here, sometimes it may not start at the origin, which you have seen in the previous examples as well. For example, in your example 2. Okay, I want to also point out that in the cumulative frequency curve, okay, the numbers that we get are purely an estimate. Alright? So if let's say I want to find out, okay, the number of cows that can produce 5 liters or lesser amount of milk, okay, if I were to read 5 liters and I find this number, that will actually be 11. Okay, it doesn't mean that there are exactly 11 cows that produce X or that produce 5 liters or less. Okay, it is purely an estimate because these numbers over here was derived based on your plotting from here and here. So all the values that you're reading from a cumulative frequency curve is purely an estimate only. Okay, you are not given any precise data about the exact amount of milk that the cows each produce. Okay, so that's the reason why in your usual question they will always say estimate. Okay, and when they say estimate, it is a result of your cumulative frequency curve. Okay, the way that it is not going to give you precise information, rather than asking you to round off or anything. Okay, so please don't misinterpret the question. Now in B part I, we want to find the number of cows that produce less than or equal to 9.4 liters of milk. So what would your answer be, Chloe? 50? Does anyone disagree? Okay, so 9.4 liters would be second line from 9. Okay, and we see that it reaches about 50. Would anyone think of maybe giving me 49.5? 49.5? You would think so? Okay, there is nothing wrong if you think of 49.5 as well. Okay, I just want to explain. That's not possible to have 49.5 cows, right? But what did I say already? This is an estimate. That's why your numbers can be. It is possible, okay, to not have whole numbers, okay, that make sense to the information. You understand what I'm saying? Is it 49.5? Or you want 49? 49 a bit hard, right? Not really, right? 49 is it here? I would say you can give it 49.5 lah. But I will not accept 49. Am I right? Let me zoom in. This line, right? This blue line, 49 is here then. Slightly beside it, right? Okay. Of course, I'm trying to encourage you to have better accuracy lah. Okay, I wouldn't quite say 49, but usually in the exam there are more lax with more wider range of answers. So maybe 49 will also be accepted. Okay, but we need to practice our skill in reading more accurately. Okay. So then part 2, the fraction of the 70 cows that produce more than 7.4 liters of milk. Okay, so what would your answer be in this one? Dylan, what's your answer? It's part 2. 41 over 7, how do you get that? Sorry? 41 over 70. 70, yeah. 70 minus 29 over 70. So you got 41 over 70. Are you all agreeable to this? Does anyone have anything else to offer? Okay, so 7.4 liters would be here. Okay, you could read it as 29, or I will also accept if you give me 30. Okay, so I will also accept 70 minus 30 over 70 equals to 4 over 7. That is fine as well. Okay, because the line that's been given to you is quite thick, so there is that possibility. Part 3, find the value of x if 70% of the cows produce more than x liters of milk. So we find the number of cows first, which is 70 over 100 times 70. That's 49. Okay, that produce more than x liters. So what is the value of x? Junyang, what's the value of x? Sorry? 6.4. Okay, how do you get 6.4? Where do you read? And what number do you read? 21, and you got 21 by? 70 minus 49. Okay, then we can find the number x equals to 64. That's 6.4. So 21 will be here. Okay, read at this, and then you find that 6.4. In this case, it's a clear answer. I will not offer any other alternative solution. Okay? I'd like you to work on your textbook, page 72. Practice now too. Joseph, I think you want your birthday to be terrible, right? I've never ruined anyone's birthday before, so don't make me ruin yours. Okay, about 3 minutes. Bernice, what's your answer for part I? 180. You all agree with that? Say you don't agree? You know why 180? 179. Do you think it's possible to read 179? You know where's your mistake? What is one box? The size of one box in the diagram? The scale is 5 squares to 25. 1 square is 5. So it cannot be 179 200, right? So need to have that realization. Okay, so it should be 180. And part 2, what would the answer be, Amanda? 200 minus 40. Okay, yes. Wait, okay. Wait. So let me put Amanda's answer down first. So 200 minus 40 over 200, right? And we get 4 over 5. Okay. So just now, Bavin asked and try to understand why Siying actually gave 179. And you're saying that it is because it is below it is a bit below the square. You sure or not? I really don't think so. Oh, but this graph, this question say that they are all about less than xmg. This is a less than graph. You understand? Yeah. So even if you're trying to argue that the graph less than equals 2, but then the question asks for less than, you also cannot discount minus 1. Why you minus away 1? Why not 0.1? Yeah, I know. Yeah, but I'm trying to say that that logic would not actually work in case anybody else would think that way. Okay, so that logic wouldn't work at all. Yeah, because it's not justified that you can minus 1 and not minus 0.1. Okay? And then part 2, okay, going back to Amanda's answer. So the fraction of the total number of oranges of 26 mg or more, do we all get 4 over 5? Get it up? Okay, and then in part 3, what will your answer be, Joanne? Part 3. 29.6. You say that? 29.6. How do you get 29.6? Can we read to such accuracy? 29.8. Can we read to such accuracy with a graph like that, with a scale like that? 29. Oh, okay, 29. Okay, sorry, it's red. Okay, so 40% would actually be how many? Okay, let's just. This is P, right? So 40% of 100, sorry, 40% of 200, that would give us 80. So we want 200 minus 80, which is 120. And at 120, we would be getting this value here, right? $120 is at this point. Am I right? 120 is about here. Correct? What's wrong? Okay, so therefore you get about 29.8. Yes, that's fine. 2 divided by 10. Any other answers? 30, I will accept it as well. Because it looks very close to it. Okay? Questions? Both are fine. Any one of it is fine. Yeah. Okay? Yes, in this particular case. No, it's not always possible. It depends on the point point they ask you to read. Yes, depends on question. This I cannot give you a fixed answer. Alright, next we look at example 4, last question for today. Something different, not just about reading off. You need to understand the question. So the heights of plants planted in our garden is recorded and represented in the cumulative frequency curve below. Okay. Example 4 in the worksheet. We want to find the unknown values of A and B in the group frequency table below. So this example they gave you some hints already, where between 100 to 120, reading from the graph, okay, you find that this value here is 30. Okay, so the number here is 30. So because 100 started off at 0, 30 minus 0, that's the reason why you get 30. For 80, it is between 120 to 140. At 140, you will read that it is 120. Right? Okay, no. Did I read it wrongly? 50 divided by 10, 5, yeah, correct. 110, sorry. Okay, so 110 minus away 30, you will get 80. Okay, therefore, what would the value of A actually be? Charmaine, what is your value of A going to be? Sorry? How do you get 45? 155 minus 80 minus 30. Why do you want to do that? We just now did our 80 by taking 110 minus away 30, right? So I can just take my reading here at 155. Because I'm looking at between 140 to 160. So I take 155 minus away 110. Okay? And we get 45. Right? And B will be equals to Zhen Quan, what do you get? Sorry? 40 minus what? 160 155. Okay, so 160 minus 155 and we get 5. Okay? Questions? If not, 3.1 is done. One more question printed here already. Do you let's see, my next lesson review is next Wednesday already, right? But then I don't see Thursday and Friday. Next week what? Chinese New Year already, ma? Correct? Then next Wednesday, if I see you, I will do 3.2. And the next Wednesday when I see you, 3.2. Then you have your EMAT WA1. Your more Wednesday? Okay. Wednesday, this homework, will it be due? I will promise you, okay, by 3.2, I'll let it due after the WA1. Okay? Yeah. Okay? So, I expect myself to be able to finish 3.2 here lah. Okay, if I give homework, I'll let it be due after the WA1. Okay? So, this one due 10 lah.